Chapter 1, Section 4 is going to be over properties of rational and irrational numbers. So in this section, we are going to go over what the definition of a rational and irrational number is and be able to see some examples of them. And then we're going to be looking at what starts happening if we start performing operations with rational and irrational numbers. So when I'm looking at a rational number, so all of these over here on the left of your screen would be considered rational numbers. The 7, the square root of 169, and then we've got some decimals here. Negative 1.131313, 24.555, 15.47. So rational numbers, the true definition of them, would be anything that could be written as a fraction, or if you are having a number that isn't given to you in the fraction form, like if you do see one of those decimals like up above, the decimals have to either be terminating, which means that they have to end, or they have to be repeating. So up above, all of those numbers could technically be written as a fraction if I wanted to. Like 7, I could put 7 over 1. The square root of 169 is 13, so I could write that as 13 over 1. And then those other numbers, even though they look like decimals, the decimal portion had to come from some type of fraction. So I could write those decimals as fractions instead if I wanted to. But the important thing to look at those decimals is some of them have a repeating decimal, like the 131313 and the 555. If you notice at the end of the number it has that dot dot dot, that dot 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 means that that number continues on after that point. They just stopped writing it. And so those would be repeating decimals because they would continue that 131313 pattern or the 5555 pattern. The last one, the 15.47, it doesn't have a dot dot dot. So to me, when I see that, that means that 0.47 was the entire decimal. So it terminated, it stopped. It didn't keep going after the 7. Now, irrational numbers, so those would be all of the ones over here on the right. These ones are a little bit different in that these would be numbers that can't be written as a fraction. Or they have non-terminating, non-repeating decimals. So if I took the square root of 2, or down here the negative square root of 7, those would not be nice numbers. They would be really long decimals that would have no real pattern to them, or they would have nothing that would make sense, or have a way for me to write it as a fraction. And you might see that with these decimals here that I have examples of, like there's no pattern to those numbers, and they would continue to go. Probably one of the most famous irrational numbers is pi. You know, we know pi if you shorten it as 3.14, but pi is a number that technically doesn't ever end. It has this long decimal that follows it, and people have calculated pi out to millions and millions of decimal points, and they've never found a pattern. It's never repeated itself. So that would be considered an irrational number because it doesn't have anything that we could see as a definite pattern or repetition. So those are the main differences between those two types of numbers. So let's start looking at what are some things that start happening if we add or subtract or multiply irrational or rational numbers. So I first want to look at what happens if I add two rational numbers. So I'm going to put a couple of examples underneath number 1 here. And what I want you to do, if you have a calculator with you, I want you to try to add these numbers and see what type of number you get and see if they have anything in common or if you seem to notice anything about the answers. So when you added these numbers together, 2 plus 3 would have been 5. 7.1 plus 2.3 would have been 9.4. And a half plus a third would be, as a fraction, 5 over 6. Or if you did get the decimal, it would be 0.83 repeating. The 3 continues to go on. So if you look at all three of those numbers, they all could be written as fractions. And those that have the decimals, they either terminate or they repeat. So hopefully you notice that these numbers would be always rational. So anytime you add two rational numbers together, it's always going to give you a rational answer. Now, if we look at examples for two irrational numbers, so see what happens if you add pi plus the square root of 5, and if you add the square root of 2 plus the square root of 3. So when you did these ones, for that first one, pi plus the square root of 5, I got 5.377660631, and most of the time, like on a calculator, it might stop there, but it doesn't end. It would continue to go on. I just don't maybe see the rest of the number, because my calculator can only show me so much. When I do the square root of 2 plus the square root of 3, that would be 3.146264437. And again, it would continue to go on. Now, if I look at those two decimals, I don't see any pattern. I don't see anything repeating. And they definitely don't terminate because they continue to go on after this point. So I'm going to make the conclusion that if I add two irrational numbers, that their sum is going to always be irrational. Now let's explore what happens when you add a rational number and an irrational number. So let's take 10 plus the square root of 2 and a half plus the square root of 3. So when I take 10 plus the square root of 2, I got 11.4142136. And again, that would continue on after that. And for a half plus the square root of 3, I got 2.232050808. And so again, I'm looking at those two numbers, and they look irrational. So anytime you add a rational and an irrational number, your sum is always going to be irrational. Now we're going to do something similar here, but with multiplying numbers, multiplying these types of numbers. So I'm going to write down a series of problems here, and when I get them finished written down and you have them copied, what I want you to do is, if you're watching this, pause the video, take some time to figure out what the answer would be, what the products would be, because you're multiplying now, and see if you can make any conclusions based on your answers similar to what we did on the previous page. So for number 1, my answers were 18 and 3 over 10. Both of those are rational numbers, so anytime that you multiply rational numbers, your answer is going to always be rational. For number 2, for that first one I got 8.311872882, and that one would continue to go. For the second problem, the square root of 3 times the square root of 12, I actually got 6. So this one, you got an irrational number, and we got one that came out to be rational. So there are going to be times when you have an irrational number multiplied times another irrational number, and you might get an irrational answer, or you might get a rational answer. So for this case, we really can't say that it's always going to be one case or the other. I'm just going to go ahead and write that you're going to get answers of both types. And finally, if you multiply a rational number times an irrational number, for this first one I got 6.283185307. And for the second one, I got 4.24264067. And those are both irrational, so we should be able to make the conclusion that if you multiply a rational and an irrational number, that it's always going to be irrational.